All right, so I've promised several times that I would, in gory detail, build a frequency table or two for you, and this problem is I think a very good one. So if I read the problem to you, it says consider the frequency distribution below, which has single values as classes. So this isn't as it's presented. This isn't group data. It's univariate data. Describe the distribution of the data. Well, let me do that. When I look down the vertical list, across from 13 and 14, I see two pretty big numbers, 18 and 10. That says there's a peak in the data around the values of 13 and 14. But if I let my eyes go down further to 18 and 19, the frequencies across from those two values are 16 and 10. All the rest are 7 or less. So there are two modest peaks. You would call this data bimodal, right? So let me go on with the question. The question says use this frequency distribution to create two new grouped frequency distribution, one with 4 classes and one with 6. And the second question says if you do that, what kind of resolution do you have with 4 and 6 classes? Does the frequency distribution with 6 classes capture the distribution of the data? Does the frequency distribution with 4 classes capture? So this is a little bit about that discussion that we ran through about the optimum number of classes for a given frequency distribution. Too small, you lose the resolution. Too large, you just make yourself a headache. Remember, the recommendation from OpenStax was use a number of classes like 5 to 20. So let's test that out. Let's go to the whiteboard now and go ahead and work through this problem. All right, see you there. All right, so I've transposed the frequency table over here on the side of the board, and what I'm going to do over here in the blank space is, as we were asked to, let's group this data in two different ways. One with four classes. We're going to let n be the class number, and one over here with 6 classes. And let's compare those at the end of the day. Okay, so if we want to get started on both of these, the first thing you have to do is to calculate a class width. Yeah, and you might remember that the class width, to do so, all you have to do is find the maximum value over there, the minimum value over there, and then divide by the number of classes. So on this side, for 4, in both cases, the maximum value is 21, the minimum value is 10. And over here, with 4 classes, we're going to form that ratio. And over here, with 6 classes, we're going to form this ratio. This number is 21 minus 10 is 11 divided by 4 is what, 2.75, I believe. And over here, this is 21 minus 10, 11 divided by 6. Not quite 2, I believe it's 1.83333. Okay, so the next step is you get creative and say, boy, I really don't want to deal with fractions. I really don't want to deal with continuing fractions. Let's round up in both cases, okay? You might remember the discussion that says you can round for convenience. Don't round down, round up. So let's pick the class width over here as 3. And let's pick it over here as, if I round that up, I round it up to 2. Okay, so we've already done a lot of the work. All we have to do now is identify the minimum number. You can't go wrong by finding the minimum data value, and that's 10 in both cases. And now with that, I can start building up these tables. So the tables over here, let's go class limits. Right here, and I've got 4 classes, 1, 2, 3, and 4. And I've got a lower limit right here and an upper right here. And the lower limit in both of the cases is the minimum, 10. And let me fill out the rest of the limits, and let me do so by just adding 3. If the
Lower limit in the first class is 10. In this case, in the second class, it's 13. Here it's 16, and here it's 19. And I'm going to do the same thing over here. Here come the class limits, and I'm going to have a lower class limit and an upper class limit. And I'm going to have 1, 2, 3, 4, 5, 6 classes. The first one starts with 10. The class width in this case is 2, so it goes 10, 12, 14, 16, 18, 20. I'm a long way down the road. I just have to fill in the upper class limit now. If this is 10 and this is 20, this one has to be 12. And again, they're all going to increase by 3. So this one's 15, 18, and 21 is going to capture our last data point. So things look good over there. Same thing here. If this is 10, this is 12, this must be 11. Again, up by 2 every time, so it's 13, 15, 17, 19, 21. Still looks good. And really all I have to do now is populate each one of these classes with the frequencies that are over on this side. Okay, so if I fill in this, I'm looking for the total number of data points here between 10 and 12 inclusive. That's these guys right here. There's 11. All right. Now everything between 13 and 15, there's 13 to 15. 28 is 32. 16 to 18, 9 plus 16 usually is 25, and then these last 3, 16, 18. Okay? Let me go do the same thing here. This class structure goes from 10 to 11. It's these two, give me a 4. 12 to 13, give me a 25. 14 and 15, these two, 10 and 4, 14. 16 and 17, 9. Did I do that right? So yeah, 9. 18 to 19, 26. And 20 to 21, 8. Okay? So there they are. There's the two tables. And now the question was, do these tables, do both of these tables capture this bimodal structure that we see here, right? There's a peak right here. 18 and 20 are significantly higher than their neighbors. 16 and 20 and 10 are significantly higher than their neighbors. Peak here, peak there, bimodal. Let's look at this. The best thing I could do, maybe, is just sort of draw this distribution this way. Like this be 11, this be 32, this be 25. And very roughly, this goes something like that. I don't see two bumps there. I see one bump. If I come over here to the 6th class and do the same thing, I'm going to go from 4 all the way up to 25, down to 14, down to 9, back up to 26, and down to 8. There's the 2 modes. Right? One right here and one right here, which more or less corresponds to this one and this one right here. Okay, so it's just a little lesson on, in 2 ways, just to see how to set these things up. And at the same time, to see that you have to be careful with the number of classes that you choose. Too few won't give you enough resolution to see the structure of the data. Too many is just a pain in the neck. Let me do one last thing here. Take 2 minutes. I haven't done this very well. I'm going to kind of in miniature restructure this to go ahead and finish through the boundaries here, okay? So I've got this little 4-class system with a lower and an upper limit structure. It's 10, 13, 10, 13, 16, 19, and over here it's 12, 15, 18, 21. And now let me jam the boundaries in here, okay? And the boundaries are gonna have an upper and lower. So this is the, yeah, I really have kind of run out of room on the whiteboard here. But if this is the limits, the boundaries capture the numbers between these classes, if you will. So between a class that goes 10 to 12 and a class that goes 13 to 15, there's 12 and a half on the upper side, okay? And on the lower side, there's 9 and a half. And again, each one of these increases by the class width. So each of these go up by 3. And you can see those two across the way are the same. 15.5, same as this. 18.5 will be the same as this. 18.5 and 21.5. It's really as simple as that. If we wanted to continue, we would go ahead and put the frequencies right here. I'll just get them down. 32, 25, 18. I didn't think to bring my calculator in. If I did, I could have calculated the relative frequencies. I'm going to write them like this. One thing we should have done is to add up this total frequency count. If I do that, I get 11, I get 29, 39, 43, 45, 52, 68, 78, 86, okay? And just to be sure, hopefully we captured all of those here. 11 plus 32 is 43, is 58, sure enough is 86. I caught every one of them. So if I want to calculate the relative frequency, I just find what proportion of this 86 are in this class. And that's the fraction 11 all over 86. This guy is 32 all over 86, 25 all over 86, and 18 all over 86. If I add all of those up, I'm going to get 1. And I saved you from watching me with the calculator find out what those fractions are. And finally, if you want to calculate cumulative frequency, remember the cumulative frequency is the sum of all of the counts in a given class and all that went before. So there's no before 11. In the second class, it's 32 plus all that went before, the 43, some of this and this. In this class, it's the 25 plus all that went before, it's 25 plus this, what I say, 68. And the last class will capture all 86. There you go. Okay, geez, there's a total nightmare there, but I think you see how creation of these things go now. All right, thanks again.